In 4.4, we're learning about complex numbers. So an imaginary number is what we get when we take the square root of a negative. So the square root of -1 is the imaginary number I. And what a complex number is, it's a combination of a real number and an imaginary number. So in this example right here, A is a real number, and then B is the coefficient in front of the imaginary number. All right, so when you're simplifying something with a negative radicand, you want to take out the I first. And now we could simplify radical 18 a few different ways. So if it doesn't come to you right away, you can make a tree diagram. All right, so since 18 is 2 times 3 times 3, if there are 2 of something, you can bring that out front. But if there's only 1 of something, that has to stay inside. So our final answer is 3I rad 2. All right, so for number 2, I can remove the I first. Now another strategy is I can just look at it and maybe I realize that 25 is a perfect square and it goes into 125. All right, so the square root of 25 is 5. So I can move a 5 out front. Now this 5 has to stay inside because it does not have a partner. And if we look at this, so imagine that as x times x times x times x times x. So whenever there is a pair, you could bring one out. So one of them can come out, the other one disappears. One of them can come out, and the other one disappears. So 2 x's can come out. And then this last x does not have a partner, so that has to stay inside. All right, for number 3, we can multiply those together and get -14i squared. However, I squared is equal to -1. So -14 times -1 is 14. All right, so for number 4, it is really important that you simplify these first and not multiply them together first. So first take out the I for the first term, then take out the I for the second term. All right, the i's can multiply together and make I squared. All right, and instead of multiplying the 10 and the 15, I'm actually going to break them down. I'm going to break down 10 into 2 and 5. 15 is 3 times 5. I'm going to write it as 5 times 3 so that I can see this pair next to each other. All right, so the I squared becomes -1. One of these 5's can come outside. And then the 2 and the 3 don't have a partner, so those have to stay inside. And they multiply back together, and 2 times 3 is 6. All right, so -1 times 5 is -5, rad 6. All right, so if you multiply these together first, you get +150. And then when you simplify +150, you would just get 5 rad 6, which is not the correct answer. So you have to simplify each radical first and then multiply them together. All right, for I to the power of something higher than 2, it follows a pattern. All right, so I by itself, we know this equals the square root of -1, but simplified, it's just I. So I is already simplified. If you have the square root of -1, you would simplify that and just call that I. Now in the table above, we see that I squared equals -1. All right, so let's keep going for a few more exponents. All right, I to the third you can get by doing I times -1. So remember that when you multiply two powers together, you add their exponents if they have the same base. So x to the first times x to the second is x to the third. We add the exponents. So if I want to do I to the third, I can multiply I times I squared. So I times -1 is -I. All right, a couple ways I can make I to the fourth. I can either do I squared times I squared, or I can do I times -I. I would say the easier way is I squared times I squared. So that's -1 times -1, and that's +1. All right, let's do a few more. I to the fifth. So I to the fifth, you can use I times I to the fourth, or you can use I squared times I to the third. I think it's slightly easier if we treat this as I times I to the fourth. So I times 1 is I. All right, I to the sixth. We have a few options. You could do 1 and 5, 2 and 4, or 3 and 3. All right, so I think the ones with the nicest numbers are I squared times I to the fourth, because then we don't have to deal with I at all. So I squared times I to the fourth. So one more time. I squared times I to the fourth. Remember, you add the exponents. So if I want I to the sixth, I can use I squared and I to the fourth. All right, so those are -1 and +1. Multiply those together and you get -1. All right, I to the seventh. Again, doesn't matter what you choose. We have a lot of options. 1 and 6, 2 and 5, 3 and 4. All right, I'm going to use 2 and 5. So I squared is -1. I to the fifth is I. Multiply -1 times I, and I get -I. All right, last one. I to the eighth. I think I'll use 4 and 4. So I to the fourth times I to the fourth is the same as 1 times 1, which is 1. All right, so hopefully you see that it is a pattern. After this point, it just repeats. So it goes I, -1, -I, +1. All right, so the trick to doing these powers that have a high exponent for I, you just have to figure out what the remainder is if you divide that exponent by 4. All right, so if you divide the exponent by 4 and the remainder is 1, then it will equal this one. So this is remainder 1, remainder 2, remainder 3, and then if it's divisible by 4, it's here. All right, I to the 45. 45 is not divisible by 4. Now, what is divisible by 4? Close to 45. All right, so 44 is divisible by 4. So we know 44 is here. So then we start over. So then I to the 45th would just be at the top, and that would equal I. All right, I to the 15th. Well, we know I to the 12th would be at the bottom. So then when we go back to the top, this would be 13, 14, 15. So this one equals -I. So remember, all multiples of 4 would be the bottom one, and then just count from there. All right, next we're going to solve some quadratic equations, which we've done before, but never with solutions that were complex numbers. Usually we like to move everything to one side, but that's not always necessary if you don't have a x to the first term. That's called a linear term. So we have a quadratic term. We don't have a linear term because we don't have x to the first. So I could just start trying to get x by itself right now. So if I divide both sides by -9, I get x squared equals -1. And then when I square root both sides, all right, so remember, when you are simplifying the square root of -1, that is just I. But when you are solving and you square root both sides of the equation, you get plus or minus I. So again, the answer to this is 3. But the answer to this question, when you square root both sides, you put a plus or minus. All right, so for number 7, there is no x to the first term, so I could just try to isolate x right now. Divide both sides by 3, and I get -16. Now when I square root both sides, I have to put plus or minus over here. And if the square root of 16 is 4, then the square root of -16 is 4i. All right, after we divide the 4, we see that x squared equals -6. Square root both sides, plus or minus on this side. All right, so 6 is not a perfect square. If we broke down 6, we would get 2 times 3, and there are no pairs there, so we can just pull out the I. On the back, we are going to learn how to add, subtract, multiply, and divide complex numbers. But first, let me reintroduce standard form for a complex number. So you want to write it in the order a plus bi. So the real number goes first, and the imaginary part goes after that. All right, so in number 9, these are not attached to an I, so that has to be the real number. Same here. So because those are both real, and it's part of an equation, those parts have to equal each other. And we could solve that. 2x would equal 6, so x equals 3. And now the parts in front of the I, those have to equal each other. So y minus 4 would have to equal 2, so y is 6. All right, with addition's pretty basic. You just treat the I like it was any other variable. So we're just going to combine like terms. The parentheses don't really do anything here, so we're going to add 6 and 1. We get 7. -4i plus 3i is -I, and that's it. All right, for number 11, just have to be careful to distribute the negative to both items on the inside. So the negative hits the -4i and makes it a plus 4i. All right, now we combine like terms. 3 minus 5 is -2. -2i plus 4i is 2i. And remember to keep it in a plus bi form. All right, for multiplying, you're going to FOIL. 2 times 3 is 6. All right, so that was first, outer, inner, and then our last terms make -I squared. All right, and then 2 things to do here. One is combine the i's together, and then the other is replace I squared with negative 1. All right, so I have 6 plus I plus 1. So we have 7 plus I. All right, another foiling problem. 5 times 4 is 20. 5 times negative I is negative 5I. Inside makes negative 8I, and the last terms make plus 2I squared. All right, this middle part makes negative 13I. This 20 is going to combine with the 2 times negative 1. All right, so this is negative 2. Add that to 20, I get 18. And remember, the real number goes first. All right, so when you are dividing, it's a different process when your denominator looks like a plus bi compared to when a is 0 and your denominator just looks like bi without the a. All right, so when the a is 0, so when the denominator just looks like bi, there's no real number being added in front of it. All you have to do is multiply top and bottom by I. All right, so pretend this is in parentheses. If we distribute this way, we get 5I plus I squared. And then the denominator would be 2I times I, which is 2I squared. All right, I'm going to do 2 steps at once. I'm going to rearrange it. I'm going to replace both of these I squared with negative 1. So on the top, the I squared becomes negative 1, and I'm also going to change the order. All right, on the bottom, I have 2 times negative 1, which is negative 2. All right, and then a couple things that I don't like. So for one, I don't like the negative on the bottom. And then your final answer has to be in a plus bi form. So we're going to break that into 2 fractions. So negative 1 divided by negative 2 is positive 1/2. And then make that a separate fraction. Don't leave the negative on the bottom. So it becomes minus 5/2 times I. All right, so now it looks like a plus bi form. All right, so I was just saying that when your denominator is just bi, you multiply top and bottom by I. When your denominator looks like a plus bi, you're going to multiply top and bottom by something called the conjugate of the denominator. All right, so think about what you do when you conjugate in your foreign language class. When you conjugate a word, usually you keep the front the same and you change the back. So we're going to change 3 plus I. We're going to keep the 3 the same, but the plus I becomes minus I. So the front stays the same and the back becomes the opposite. And if we do something to the bottom, we do it to the top. All right, you could add parentheses here if it helps. Distribute the 5 on top. You get 15 minus 5I. And then in the denominator, you actually don't have to FOIL. All right, so I'll show you why you don't have to FOIL. So I will FOIL this one, but in the future, when you are multiplying something by its conjugate, watch what happens when you FOIL. So I did first. So whenever you FOIL something times its conjugate, the outer and the inner are going to cancel out. So you really just have to do first and last. So you really just had to do first and last together. All right, so 9 minus negative 1 is 10. Right, so the denominator becomes 10. And now we can make it into a plus bi form, and we could also reduce it. And it doesn't matter what order I do those two things in. So I'm going to change it to a plus bi, 15 over 10, minus 5 over 10 times I. And let's change that, or let's reduce that, 3 over 2 minus 1 half I. All right, one more. So we have a plus bi on the bottom. We're going to multiply it by the conjugate. Keep the front the same, and the back part becomes the opposite. All right, distribute the 3i. We get 6i minus 12i squared. Right, on the bottom, you don't have to FOIL if they're conjugates. Just do first, so 2 times 2, and last, minus 16i squared. All right, I squared is negative 1, so negative 12 times negative 1 is positive 12, and then I still have the 6i. All right, I'm going to simplify the bottom now. I have 4, and this is negative 1, so 4, and then minus 16 times negative 1 becomes 4 plus 16. So I have 12 plus 6i over 20. Let's change that into a plus bi form and also reduce it. So 12 over 20, those are both divisible by 4. 3 over 5 plus 6 over 20, those are both divisible by 2. 6 over 20 becomes 3 over 10i. All right, that is all for 4.4.